Now we continue our lesson with derivative of logarithmic functions. The learning outcomes of this lesson is to differentiate the natural logarithmic function, or normally known as ln x. For x greater than 0, the derivative formula for natural logarithmic function ln x is given as d over dx ln x is equal to 1 over x. When we apply the chain rule to the derivative of logarithmic function, or if we differentiate the d over dx ln fx, it is equal to 1 over fx times with f prime x. So if we look at here, the differentiation follows the differentiation for ln x, but we replace the x with fx and multiply with f prime x. Now we look at the first example, y is equal to ln x cubic. Y is equal to ln x cubic is in the form of y is equal to ln fx, where fx is equal to x powers of 3. Therefore, the differentiation for ln fx have to use the chain rule, which is differentiate ln fx is equal to 1 over fx times with f prime x. Here, if we differentiate the fx, we will get 3x squared. And since we use the chain rule for ln fx, so here we get the dy dx as 1 over x powers of 3 multiplied with differentiation for x cubic, which is we have 1 over x powers of 3, 3x squared. So this is 1 over fx is x cubic, and this is the f prime x, which comes from here, 3x squared. And if we cancel out the x squared and x cubic, finally we get the dy dx as 3 over x. In the second example, we want to find the dy dx for x squared multiplied with ln sin x. Y is equal to x squared ln sin x is in the form of u dot v, where the u is x squared and the v is ln sin x. Differentiate the u, we get u prime is equal to 2x, and differentiate the v ln sin x, we need to use the chain rule. Differentiate ln fx is equal to 1 over fx times f prime x, and thus we get 1 over sin x cos x. Since the y is in the form of multiplication or product rule, so here we use the formula for product rule for differentiation, u v prime plus v u prime. Every time we need to write the formula for product rule. And after that, we are going to substitute the u, v, u prime and v prime in the formula. Thus, we get dy dx is equal to x squared 1 over sin x cos x, which is x squared from here. And 1 over x squared cos x is the v prime. It is come from here. And ln sin x is the v, and 2x is the u prime. So, towards the end, if you look at here, cos x over sin x is equal to cotangent x. And lastly, we get the dy dx is equal to x squared cotangent x plus 2x multiplied with ln sin x. That's all for today.